Why does Oracle sometimes use full table scan even when an index exists? Why does one query use index range scan while another uses index fast full scan or skip scan? Most developers memorize execution plans, but very few truly understand why Oracle chooses them. In this complete masterclass, you will learn various index scans like full table scan, index range scan, optimizer statistics, etc. So many concepts which are related to SQL tuning. You will not just learn theory, you will understand how Oracle thinks. By the end of this video, execution plans will be finally start making sense to you. So let's dive into the complete Oracle Index Scan Masterclass.
What is access path? Access path means once we give select statement or once we submit select statement to Oracle, what is the access or what is the path followed so that it will complete that particular SQL statement. It can be insert, update, or whatever it may be. Okay, so is it going full table path or is it using row ID? If it is index, there are some flavors in index. So many paths are there. So those things we'll discuss. So how Oracle will come to conclusion? So how Oracle will decide like which piece of software will give this information? That is nothing but optimizer. So optimizer chooses the access path based on what information? Based on how many available access paths are there. Okay. And what is the estimated cost? Estimated cost means in terms of resources, CPU, IO, sorting, all those things. Okay, it is not monetary. Anyway, it will convert into monetary only. Whenever people take up tuning assignments, it will be in terms of this. They will convert these resources into monetary, and they will tell we will reduce this much of your this thing like that. And are there any hints? Okay, these are some advanced things. Okay, baselines and profiles, some advanced things. So what are the available optimizer modes? Previously, rule-based and cost-based was there. Now this is desupported. It is desupported. No more it is there. Cost-based optimizer means it chooses path based on what information? Based on table statistics, index statistics, so many other statistics. Okay? It will not follow any rule-based optimizer. It will have some rules. Rule 1, rule 2, rule 3 like that. So it is not like that. Cost-based optimizer, it will find out various statistics. Based on that, it will try to give you optimal plan. If that is also not, we are not happy, then we can change. See, even though it is not there in the newer versions, but rules used to be like this. Rule 1, single row by row ID, single row by cluster join, hash cluster key. So first it will start checking, given a select statement. So if this is not there, this is not there. So then it will go to the next one like that. Single column index, bounded range search, all these rules internally. Okay. First it will start with rule 1. If this is satisfied, it will follow that rule 1, even though it is there in index also. Because of that only rule-based optimizer is desupported. See, suppose I am retrieving 80% of the table, which is better? Full table scan. Okay, but with rule-based optimizer, if at all it sees index, then it will go for index scan. Okay, so there, those are the issues with rule-based optimizer. Okay, cost-based optimizer will not do like that. It will try to analyze so many ways. So I said table statistics, right? What are table statistics? Whatever information you have in user underscore tables or DB underscore, I should say DB underscore tables, because this will have maximum of the information compared to user underscore tables. Number of rows, number of blocks, empty blocks, available free space, chained and migrated rows, average row length, last analyzed date, sample size. I have listed only few. Internally, it will be accessing some more statistics also. I am showing you only very little, but internally so many statistics it will try to optimizer will be gathering. If you take index stats, what is the index height? How do we get index height? V level in the So number of leaf blocks and distinct keys, number of index entries, average number of data blocks per key. So based on all these things, it will try to find out the access path, best or better access path. If you take column statistics, number of distinct values, lowest value, highest value, last analyzed date. Okay. How does it get? DBA tab called statistics. Okay. So why we need statistics? Without, in the absence of statistics, what will happen? I will present you a scenario. Today a bigger load came. What I did is 50% of the table I have deleted and 1/3 of the table is inserted. Okay. And next day, today night I have done this ETL activity, and tomorrow reports are accessing this data. Users are complaining. Reports are very slow. Actually, I deleted 50% of the data. I inserted only 1/3 of data. So my deletes are more than insert. So data is less. Why users should complain the performance issue? Any idea? It is using index, but still it is slow. Whatever you said is also one reason correct, but any other reason you can think of? They did only this much, They just deleted and they inserted. That's all they have done. Nothing else. As part of ETL job, only this is done.
Contains unnecessary leaf blocks.
Yeah, fine. I agree. Yes, I agree. So, how to overcome it? How do you tune it?
We need to analyze the table.
Okay, so you should analyze the table. That is the correct answer. Because they just deleted and inserted, they did not analyze. So how will Oracle will come to know? Okay, as per some internal algorithm, it will update, but it updates on its own internal piece of software. Okay, because it's a very bulk activity. 50% of the table is deleted, 1/3 is inserted. So there is a lot of change in row count and the row distribution also. See, this is same scenario. Okay, in production everything was going to full table scan. You can see the problem was they did not analyze the tables. Okay. Once the table analyzed, full table scan stopped. They started using indexes. Okay, I changed it a little bit and I presented. Okay, this is one scenario. That is another scenario. Okay, so first thing, first we have to see statistics is very important. Oracle, without that, optimizer cannot take a correct decision. Next, let us see what are these access paths. First access path is full table scan, or we call as FTS. Okay, so full table scan, is it bad always? Because many people say full table scan, so there is a problem. Do you think always full table scan is a problem, or is it advisable sometimes?
Not always, based on the request.
Based on the query result, amount of the query result. Okay, if it is accessing most of the table, better to go with full table scan. So it is not always bad. We see what is the scenario. Based on that, we'll tell FTS is better or it's not better. So in FTS operation, it reads till high watermark. Whether you have empty blocks, used blocks, partial data blocks, whatever it may be, it reads till high watermark. Okay, high watermark we discussed, right?
Yeah.
So truncate resets the high watermark back to the start of the table. FTS uses, for full table scan, there is a concept called multi-block IO. See, in general, I told you, right, initially, whether you need it or not, minimal data blocks are assigned. DBT table, only 3-4 rows are there, still it is having 5 data blocks.
Yeah.
Okay, because minimal, the way, even if you say select star from also, it won't bring only one data block. That minimal IO, what is set by Oracle internal, that is, those many number of data blocks were brought. So, how to make full table scans faster? See, sometimes we can't avoid. We need full table scan, but can we make it faster? Yes. There is a parameter called DB file multi-block read count. If you set it to 16, then in one IO, 16 blocks are brought. If you set it to 32, always it should be 2 power n. If you set it to 32, 32 blocks are brought. In this way, you can make full table scans to perform better. Okay. this DBA has to set DB file multi-block read count. See, we generally, they will set this parameter and they monitor in how much full table scans are better. If you set this, even if you have small table also, it will try to get entire thing, right? Unnecessarily, it's not required. So generally, how DBAs set this parameter number means, suppose first they'll set it to 8, they check full table scans for the bigger tables, how it is performing. Once they set 16, then they again perform. Just like that, they won't perform. Like, sometimes when you set to maximum, it might affect the small table issue also. Unwanted things also they will be coming, right? See, at the maximum value, whatever you said is suggested only for warehouses, not for OLTP. Warehouses, it is whatever you said is correct, because data will be huge, and some places we can't avoid full table scans in warehouse and data mart, so it's better to go for it. But OLTP, that's what I'm telling. Whatever Oracle gives feature, always it comes with some pros and cons. Always we should be aware of it. So just because Oracle give, if DBA sets, it might affect some other place. That is the reason the approach I generally follow is slowly I'll increase. I'll set it to 32 and I'll monitor. And we also document, all these things. If somebody asks, and why did you change and what is the proof means, DBA should be able to give that. So that is the reason even DBAs also, they do documentation ideally, okay? If they're not doing, that's another issue. So they will put 32. Once the expected tuning effect is reached, they'll stop it. Okay? That is how they do it. In SQL Developer, I have to write a query. Here, simply I can give this command. Multi-block. Yeah. It is 128, it is set to. I did not do anything. This is a default value it has set. Okay. Because it's a new database. I created, just before start of your training. Some issue was there, so I deleted and I created. This is a default. I did not do anything. Maybe I have selected typical. See, in Oracle installations, you have typical, custom, like that, right? So I have chosen typical installation. As part of that, it has set this value. In normal production environment, we will not use typical installation. Okay. So this is this, and multi-block. This we already discussed. So in which cases Oracle will choose full table scan when no indexes are present, when a query does not have where clause, whenever you use like operator percentage where index cannot be used, okay, because it's a special operation or something. With cost-based optimizer, when a table contains small number of rows, okay. When optimizer mode equal to all underscore rows. There are optimizer mode is a parameter. DBA can set all underscore rows. Some parameters are there, okay. So they will set based on that. Oracle will. In these scenarios, Oracle will use full table scan. Okay. Next is ROWID scan. What is ROWID? That is, it tells the location of row, data file, block, that etc. Everything. Okay. So ROWID scan means some places we have seen. Do you remember the chain count row? That do you remember? Migrated rows, chain count. So how did we get those rows? Only the chain count we want. How did we get that? If you remember approach, we gave some command. That chain records came into one chained underscore list table, internal table. From there we captured row ID. Based on that row ID, we inserted and then into temp table, and then deleted from that, reinserted back. That's how we did it. Do you remember? So in what way row ID is helpful for us? If at all some particular operations, if you want by this, then definitely row ID scan is useful. Okay. But here we mentioned that row ID. Okay. Index lookup. Index lookup, you already know. First it checks that index value, index tree. Index tree leaf block will contain value and the row ID. Once it gets the row ID, it will go to this and retrieve that. Okay. That is index lookup. This you already know. There are so many flavors of indexes. index unique scan, index range scan. Whenever you run explain plan, you will be seeing all these terms. Index skip scan, full scan, fast full scan, like that. Okay, let us see each one. You remember, right? This is how B-tree is internally. Okay, yeah. Index unique scan. In which scenario Oracle will choose index unique scan? Whenever your where clause is having predicate means whatever where condition. Okay,
Yeah.
whatever where condition is called as predicate. In your where condition, if you have unique index or primary key, whatever it may be, okay, then it will go for unique scan. The method for looking up single key, because unique, right? Whatever where clause you are giving for one particular value, only one value will be retrieved. Okay. So always returns a single value index scan, because it is applied only on unique and primary key columns. So obviously you will get only one result output for this. Like employee ID 5, you will get only one record from employees table, and employee ID is a primary key. So it will use index unique scan. DbVidya number equal to 10. Yeah. Can you see here unique scan?
Yeah, unique scan.
Okay. I wanted to show you that. So that is unique scan. Next is index range scan. Whenever in the following scenarios it will use, okay, when you are accessing multiple column values, okay, and also whenever your predicate contains range operations between, less than, greater than, like that. Okay, so let us see. Okay, maybe because it is retrieving more than all rows, so it has gone to full table scan. It is having only 2-3 rows. Let me give like 1T. Let me see. I don't know what records are there. I'm just checking. It used how many records came output? Okay. Only one record came. It is range. Can I see here range scan?
Yeah, range scan is there.
Okay. So access predicate, you can see. These are the terms now we are discussing. Table access, access predicate, department. This is a filter condition also it will give you. Okay. What filter condition for which? Just taken this. Okay.
So it will show for each predicate.
Yeah, each predicate. It has to. So Oracle, so I can't promise. It has to. If I say and dname equal to, what is the result? Operations. OPERATIONS. It's a good name. Can you see? One predicate, dname equal to operations. Next one is greater than 30. So if you have 10 predicates, 10 filter conditions will be there. Okay. Clear?
So one is showing range scan and
So see, maybe what I can think is, first it has department number greater than 30 that it has captured. For those things it got the row IDs, right? It is using DEPT PK. For those row IDs, by using index row ID, it has got a T name. That's all. So that is index range scan. So till now, how many scans we discussed?
one is full table scan, second is index unique scan, and now index range scan.
Even row ID scan. Okay. Row ID scan.
Okay.
This one. Okay.
The ROWID scan, I didn't exactly get.
See, sometimes we specifically say row ID, like row ID equal to this.
Oh, in that where condition?
Yeah, where condition also, even when Oracle is doing, like in previous case, first it retrieved row IDs from one operation. These row IDs are passed on to the next step. next step. So that step also it is ROWID internally. Even if you explicitly say where ROWID equal to, then also it will use ROWID scan. Okay. So this is index range scan. What is index skip scan? Okay. Suppose if you have composite index say you have on two columns, then you in your predicate you are not using leading column.
Okay.
Then previous versions Oracle used to ignore, but in newer versions it will skip the leading portion of the tree and it will use the sub part of the index. That means it will skip the leading edge. It will use the index. See, I am having index on A comma B. Okay, two columns. But in my where clause I have only where B equal to so and so. But my tree starts with A, right? But I'm not using in the where condition A column is not there. So what it will do is that A portion of the index tree it will skip it and it will start searching from the B part. So it is skipping some portion. It is called index skip scan. It is not that it will skip the index. Okay, it will skip the leading edge of the predicate. Okay. Suppose if you have ename commission from employee where it is represented by index SS, it is used only for composite and multi-column. Obviously, to skip you need composite index. Okay. So if you are having index on ename and commission, example, index is there on salary and commission. Okay. But I am using only commission here. So what it will do, it will skip the salary part and it will try to use it. It is called as index skip scan. If you want to force it, this is a hint, index underscore SS EMP. Suppose if it is not using, it is supposed to be used. If it is not using, we will be using this hint, index underscore SS. Index full scan. Index full scan means suppose you are retrieving entire that index. See, I have index on DBT number, right? Where DBT number greater than 0. Okay. Oh, I think this will go for full table scan. Let me see what it goes. Based on that, I'll check. Okay. Maybe because I used this. Because greater than I have used, so it is going for range scan. Can you see here? Full scan. It is using index. It is using index and full scan. So this is index full scan. Okay. Most of the time, it will not go to the table. Is it a need to go to the table segment? Not required, right? All the information is present in the index tree only. Okay, so it will read entire index. That is the reason it is called index full scan. Same thing, whatever example I have shown you, same thing. What is index fast? What are all scans we discussed? Can you recollect?
Full table scan, ROWID scan.
Yes.
Index scan, index range scan, index full scan.
Yeah. Skip scan. Index skip scan. Skip scan. This is index fast full scan. Here, all the blocks of the entire index tree is read. Okay, but using that multi-block read count. Even if you want to make it more faster. Okay. Suppose I have an index on last name and salary. So no need of going to the table. All the information is present in the tree. But assuming that this table is very big. If you are warehousing environment where you are searching some example, okay, you can think of. So if I want to make indexed full scan even more faster, what it will do is the DB file multi-block read count I said, right? Multi-block IO. So this parameter value, whatever value is set, those many blocks it will retrieve. So retrieve what? Not the table blocks. It will index leaf blocks, that values it will bring. So that is what it is called as index fast full scan. Okay, it is represented with index FFS. That's a hint used. So that is about all the access methods. Okay. See here I have index on DBT number only. Okay. dname it is not having index. You agree? It's not having, right? So let us see. Do you see, is it using full table scan? No, right? Okay. So see, most they have written optimizer in better way, but still, how can they capture all the scenarios? So sometimes there will be problem which we have to tune manually.
Explore our Oracle Performance Tuning and Dimensional Data Modeling with eRWIN tool courses. Upskill with our video courses at your own pace and time. Courses are created with real-world scenarios and ready to work immediately by industry experts.